All right. Hi, I'm Ray, and today I'm going to be talking to you about juvenile carp control in Utah Lake. And I want to take a moment to acknowledge and thank my advisor, Tim Walsworth, for his help on this project. Now, I know it's the Watershed Sciences Department, and telling you about freshwater ecosystems is something we're all intimately aware of. But freshwater ecosystems are home to a large amount of biodiversity and are actually home to over 50% of documented fish species. Now, unfortunately, freshwater biodiversity is in decline, and it's declining at a rate that outpaces the decline in marine and terrestrial ecosystems. Now, one of the biggest threats to freshwater biodiversity is the threat of invasive species. Invasive species are often the target of management actions because of the negative impacts they can have on the ecosystems that they've been introduced into. Invasive species are known to threaten the potential health of native species. They can change and alter food web and habitat structures and also lead to economic losses. Now, eradications of invasive species are possible, but have most often been documented in small, contained habitats. Today, I'm going to be talking about an invasive species called the common carp, and it's been identified as one of the world's worst invasive species. Its detrimental impacts have been seen all across the globe. Now, common carp are known to change habitat and food web structures and also reduce the water quality of systems that they've been introduced into. Utah Lake has had a carp problem for a while now, and by the early 2000s, carp made up over 90% of the fish biomass in the lake. And all of these negative impacts that habitat destruction and threats to native species were occurring within this system. This was a bad thing because Utah Lake is home to the endemic, previously endangered, and currently threatened June sucker. And because of the impacts of common carp on Utah Lake habitat, it was inhibiting the recovery of June sucker. Because of this, the June sucker recovery implementation program made the goal of a 75% reduction in carp biomass and began a carp control effort in 2009. Now, to date, over 15,000 tons of carp have been removed from the system, and models suggest that that 75% reduction goal was met back in 2017. However, these same models suggest that that carp population is rebounding and no longer meeting that 75% reduction target. Now, models show that the likelihood of remaining below that 75% reduction target in the future is very low if we continue fishing with the current removal gears. Now, the current removal gear in Utah Lake is a large mesh commercial seine pulled by commercial fishermen. I'll be referring to it as a large mesh seine from here on out, just for the purpose of a tongue twister. Now, one of the reasons that this current gear isn't effective in Utah Lake is due to the fact that it's primarily fishing for adult carp, and we don't see really any juvenile carp in the catch. Now, catching only big fish is not a phenomenon isolated to catching common carp or catching fish in Utah Lake. There's a couple of factors that impact why we see big fish typically more represented in fisheries catch. And one can just be the location of fish. Adult fish tend to be out in open waters, whereas juvenile fishes are often along the shoreline in protected habitats that are just inherently harder to target. It can also be due to the type of gear that's used, whether using a hook that's too large for a juvenile to fit its mouth around, or a mesh size that a juvenile fish can just swim through. Those gears are going to target adults and not juveniles. Now, targeting adults is often a good thing for commercial fisheries, where you want your fish to be able to spawn and reproduce before they are captured and removed from the system. However, it's not a great thing for removal efforts, where even if you're fishing a large quantity, say 15,000 tons of fish, you're taking those adults out of the system, you then see compensatory recruitment, whereas the population declines, your juvenile survival rate increases, and year after year after year, you're just seeing more adults come into the system. And even if you're fishing at really high levels of effort, you're never going to really be able to dampen that population permanently. So this brings me to my 3 research objectives. The first is to characterize juvenile carp spatiotemporal distribution in Utah Lake. The second is to determine the size selectivity of alternative mechanical removal gears, trying to identify a gear other than that large mesh seine that could potentially target juvenile carp. My third objective that I'm not going to be talking about today, just for the sake of time, is to estimate the levels of effort required to meet Utah Lake carp control targets, that 75% reduction goal, with these alternative mechanical removal gears. Now, looking more closely at the spatiotemporal distribution of juvenile carp, why do we specifically care about characterizing where the juvenile carp are? Well, fish undergo ontogenetic habitat shifts where they have different life history requirements when they're young versus when they're old, and you'll often find juvenile fish inhabiting different habitats than adult fish. The literature shows that juvenile carp typically inhabit shoreline vegetated habitats, whereas adult carp move out into the open water. Now, in order to target multiple age classes, you're going to have to target multiple areas if your fish are inhabiting multiple areas. Now, this might sound great. All right, the literature says they're in the shoreline vegetation. There's a nice pic of you holding a juvenile fish in some shoreline vegetation. Easy, done, right? Oh, unfortunately not. Utah Lake poses a number of challenges to juvenile carp control specifically. Utah Lake's very large. There have only been 2 documented cases of successful carp eradication in the world. One occurred in Lake Crescent in Tasmania, which you can see up on the top right there. And Lake Crescent is only 1/10 the size of Utah Lake. Another occurred in Lake Susan in Minnesota, which is even smaller than that. And the method they used was just draining the lake and letting all the fish desiccate. Can't apply that one to Utah Lake either. So Utah Lake's also very shallow. So traditional fisheries gears that can be deployed in deeper lakes can't be deployed in the same way within the Utah Lake system. So I can't just go look in the literature, see what's catching juvenile carp elsewhere, and know it's going to work here. I also can typically not get my boat anywhere near shore. And so the commercial fishermen with those large mesh seines are pulling them with boats. And if you can't get your boat near shore, you can't use a boat pulled gear near shore. So that entire shoreline habitat is currently not being targeted by the ongoing removal efforts. Utah Lake also is it's shaped basically like a dinner plate. So especially when the water level drops down, all of that shoreline vegetated habitat that in the literature we know juvenile common carp prefer is disconnected from the lake and unavailable to any fish. So I can't just go set nets in the shoreline vegetated habitat because it's not there. So where do we target these efforts if we know we can't just take what's worked in other systems and directly apply it? Well, that brings me to my specific research questions for my spatiotemporal distribution chapter. The first of which is, how do juvenile carp catch rates differ spatially around Utah Lake? The second is, how do these catch rates vary among different habitat types? And the third is, how does the time of year when the gear is deployed affect these catch rates? Now, in order to answer these questions, I've developed a standardized field sampling protocol. You can see a map of my field sites here on the left. I actually began sampling in August of 2021, and my field sampling will run from April through October for 2 cycles. Now, I have 3 sites in the middle of the lake, even though that's where the literature suggests we see adult carp and not juvenile carp, perhaps because that shoreline vegetated preferred juvenile habitat doesn't always exist. They're seeking out refuge or protection in the middle of the lake. I also have 16 sites around the perimeter of the lake. And these are made up of the 3 different primary habitat types that we see in Utah Lake. I have 4 sites with a rocky substrate, 4 sites with a sandy substrate, and 8 sites that have a muddy substrate, with more muddy sites just because there's a lot more mud than anything else in Utah Lake. Now, at each of my 16 perimeter sites, I deploy 3 standardized gear methods. On the left here, you can see the gill nets that I deploy at each site. I actually deploy 2 gill nets, but for the sake of simplicity and my drawing skills, I just used one. And a gill net fishes by what its name might imply, and it catches a fish by its gills. So the mesh size is really important to targeting the correct size of fish. Additionally, gill nets are known to impact the health of fish that are caught in them. So I limit my set times of my gill nets to 20 minutes to limit any impacts to that threatened endemic June sucker. The second gear type I'm using that you can see in the center image is a mini trap net, also commonly referred to as a mini fyke net. And the way a mini trap net works is it has a pot that once a fish swims into it, it's unable to find its way out. It also has a lead that runs from the pot all the way to shore. And so any fish that's swimming along that shoreline is going to run into that lead and be directed to swim into the pot, where they're going to stay until I come back the next day and let them out. Not until I've counted and weighed them, though. And then the third gear that I'm using is a hand or boat pulled beach seine. Now, even though this has the exact same name as what the commercial fishermen are using, it's another seine, it's much smaller. And so because it's smaller, and at most of my sites, I end up using a hand pulled one because I also can't get a boat anywhere near shore. I am able to target that shoreline habitat with a seine, which the commercial fishermen are currently not able to do. So in addition to this standardized field sampling that I'll be doing, I'm using a couple of different pre-existing data sets. I'll be looking at standardized annual seine surveys that are collected in partnership with USU, the Utah Division of Wildlife Resources, and Loy Fisheries, which is the commercial fisheries company responsible for the removal efforts. And they have data for those large mesh seines, that gear that's currently being used in the removal efforts, going from 2012 through 2021. They also began using a smaller mesh seine that has a 3/4 inch mesh instead of a 1.5 inch mesh in 2020. And that data exists for 2020 and 21 to see if it was simply the size of the mesh of those seines that was keeping juvenile carp from being caught. I'll also be looking at some trawl polls that were conducted around the lake from 2005 to 2013. Now I have some preliminary results from my field surveys in 2021. However, just for the sake of time, I'm not going to be talking about them. If you have questions, happy to talk about it later. With these 3 data sets that I've described, I'm going to be analyzing the catch per unit effort at each of these sites using a linear mixed effects model. This is going to tell me the impacts of a number of different effects on the catch of juvenile carp at these sites. And those effects are the effect of the substrate type, the effect of the season, the effect of the year, and of lake level, and additionally the effect of the site, which is going to tell us about that spatial distribution. Now that's great. Now we can figure out where they are, but we still need to know how to catch them. So that brings me to my second chapter, the size selectivity of removal gears. Now, selectivity is the proportion of fish at an age or size that's vulnerable to fishing. And all fishing is inherently selective. This can be because of the spatial distribution of fish, the properties of the gear being used, the behavior of the fish, or even the behavior of the person fishing. So what does selectivity look like in catch? Let's say you have a fish population that looks like this, where as they get older, you see a decrease in numbers. Fish have a really high juvenile mortality, so the count of juveniles is much higher than the count of adults. If you had a gear that was evenly selective across all age classes, your catch shape would mimic that shape of the overall population. However, what we see in Utah Lake and in most fisheries is an adult selective gear where your catch rates for adults are much higher than juveniles, even though you know there has to be more juveniles in the system. So this brings me to my specific question. How does age-specific gear selectivity vary across these alternative removal gears for Utah Lake? I'll be using those same 3 data sets that standardize seine surveys, the trawl data, and the field surveys I described for my chapter 1 work. With each of these data sets, I'll be calculating the selectivity, which is a function of that catch, their catchability, the effort of fishing, as well as their overall abundance in Utah Lake. I'll then be applying different selectivity curves to these calculated selectivity data. And a selectivity curve allows you to compare the selectivity between different gear types. Now, there's a number of different selectivity shapes, just depending on the gear and the target species, and some of those are exemplified on the right. Now, this research will have a number of different benefits and implications. It'll inform the overall Utah Lake carp management strategy as far as what gears we should be using and where we should be deploying them. It'll also help inform alternative removal efforts, so some of those non-mechanical removal efforts, some of which you'll hear from my lab mate Ellie later. And for example, if we're applying poison bait into the system and we know where to target to be able to target juvenile carp, you can more effectively apply those alternative removal methods. It also can help improve other large-scale removal of common carp in other systems. For example, on the right here, you see the Murray-Darling Basin, spelled that wrong, but in Australia, where they are facing an invasion of common carp and it's threatening local systems that are relied on heavily for food and economic importance. I'd like to thank the June Sucker Recovery Implementation Program for funding this work, and I'll now take any questions. So June sucker in Utah Lake, we primarily find that the June sucker that show up and catch have been stocked, and they're stocked at 300 millimeters. So typically we're assuming the juvenile or the June sucker are over 300 millimeters in Utah Lake, whereas juvenile carp are 350 millimeters or less. So ideally, if you're targeting juvenile carp, if there's June suckers that are juvenile, you're targeting them, but currently we don't see a ton of juvenile June sucker. So there's not a ton of overlap currently. So that's the downside, make it less small and make that sucker as well, right? If we were seeing juvenile June sucker in the system, yeah.
A lot of fish have diurnal day-night movements inshore and offshore, and additionally, particularly gill nets don't fish very well during the day. They do better at night. You didn't say when you were sampling them. Are you concerned, or is there any data in the literature about inshore offshore movements?
Mm-hmm. There is, and those adult carp do move back inshore at night typically, and then back into the middle during the day, whereas the juveniles in the literature are restricted to that shoreline habitat in a 24-hour period. My trap nets are set overnight, so I set them at like noonish, and then I come and pull them the next morning. So hopefully I am capturing some of that overnight fishing aspect. My gill nets are just set during the day. We've talked about the idea of potentially trying to set them at night, but just resource limited at the moment.
Your diagram indicated you had gill nets offshore and trap nets inshore. Are all of your gear inshore and offshore?
So ideally, all of my gear would be inshore, but just because the shoreline is so shallow, all of my gears actually end up being offshore at a lot of my sites. I just didn't touch on it for the sake of time, but at a lot of my sites, I actually even have to set my trap nets like 50 to 100 meters offshore to be able to even have a foot of water so that the throat is submerged. So ideally, I'd be able to set my gill nets inshore as well, but even with just a 5-foot deep net, I have to get pretty far offshore to be able to fully deploy it. Yeah, so it's changed a little bit over the years. Back when the carp removal was more, they were catching more and stuff. They've sold them for like fertilizer. I think at one point they were selling them for like dog food or something. They've also just trucked them to the landfills, and at different times, actually just, it's not even profitable for the fishermen to drive them to the landfills. So they have at times just dumped them back into Utah Lake. So really just it depends on the timing and how beneficial the fishermen see it of what they want to do with the carp.
So you mentioned how unique, like how shallow Utah Lake is, but you also mentioned scaling this to different watersheds.
Mhm.
Do you anticipate that being a problem, like your findings being really unique to just like a super shallow lake?
I don't think that the overall findings will be specific just to a shallow lake, and there are a lot of shallow systems all across the globe. And one thing to note about carp is they're just like impossible to kill. They just don't care what you do to them. They really like the sewage effluent areas of Utah Lake, for example. So some of those crappy like puddly pond systems you think about are actually where a carp might do great. And so there's plenty of systems that are similarly shallow and just kind of messy for fishing where you would find carp. And